All right, welcome back from your break. This will be the fifth and final video in the 8th lecture of the engineering design course. We are walking through an example of how to use the house of quality diagram to implement the quality function deployment method to help with the engineering design process. Just as a quick reminder, let me go back a few slides here. There we go. We have, this is our example. We are a company that's producing a new product, a mechanical pencil, this one on the top, which has a lead diameter of 1.3 millimeters. The purpose is to address a customer need to reduce the breakage of lead in mechanical pencils. So our design solution is to increase the lead diameter, to strengthen the lead, to increase the number of breakages. There are two existing competitors. The first is a conventional mechanical pencil, which has a lead diameter of 0.7 millimeters, and the second competitor is an old style wooden lead core pencil. So we walked through, I'll move the slides back to where we were, moved through several stages of the house of quality diagram, and this is where we stopped at the end of the previous video. So let's move forward from here. Remember that I've completely filled out this house of quality diagram, but I'm going through each individual component of it so that you can see how I filled it out and why I filled it out in the particular way that I did. Another reminder, this house of quality diagram is an incredibly simplified version of a much larger diagram that you would use in a real engineering design process, a real QFD process, and I've specifically made this one very small and very simple while retaining all the key attributes so that you could see how it worked in the context of this example. So let's move forward from here. Okay, so this little roof triangle here, this is actually why this diagram is called house of quality, because a lot of people think that this looks like the roof of a house, and so house of quality is sort of a metaphor for the shape of this diagram. What this roof shape does is it gives us a way to evaluate the correspondence between our engineering requirements. So any cross-coupling or cross-linking between your engineering requirements. If you improve your ability to meet one engineering requirement by changing the design so that that requirement is better managed, are there cross-couplings that somehow affect the other engineering requirements? And so, again, the way to look at this is to look at this column, and then that column corresponds to this column in the house of quality roof, and then this column, the second one, corresponds to either this or this direction, depending on what you're comparing, and this column corresponds to this column in that house of quality roof. So wherever you have an overlap, you can put a symbol. I've highlighted the symbols here to indicate whether there's a strong positive, a weak positive, a weak negative, or a strong negative coupling between those engineering requirements. So here we see that having a large lead thickness actually does have a strong, just a positive correlation between one pass ease of erasure, and that's because the larger the lead thickness, the less lead actually gets pushed into the paper, and so the less dark the lines that come out of this pencil with the larger lead thickness, and so it's easier to erase those lines. So that's why I put a corresponding positive correlation there. There is no correlation between large lead thickness and one push actuation, so this cell is left blank, and one push actuation and ease of erasure, that's this cell, and there's actually a very weak negative correlation between them, because if you look back at the original pictures, let me go back to those slides for a moment. There they are. You can see that the eraser is actually embedded in the same spot where you do the actuation to push out the lead. So having the eraser and the lead actuation embedded in the same place actually is a negative correlation there because they impede each other's ability. So that's why that X is placed there. Okay, so moving on, we're going to look now at the customer rating. So we're going to look at how our two competitors stack up in terms of their ability to meet the customer needs. And so the way that I do this is I've just got this little square that indicates competitor 1, and I've got this little triangle that indicates competitor 2, and I've got this numbering scheme here where 3 is a good achievement of a particular customer requirement, 2 is an average achievement of a customer requirement, and 1 is a poor achievement of a customer requirement. And so I place the appropriate symbol on either 3, 2, or 1 associated with each of the customer requirements, and then I can compare the two competitors to each other. So with respect to the lead won't break, competitor 2, which is the old yellow wooden pencil, has stronger, thicker lead than competitor 1, and so it's given a higher value, although the lead is still kind of soft and easy to break. So I don't put it at 3, I put it at 2. For easy to sharpen the lead, well, it's much easier to just push the lead out of the mechanical pencil than it is to get a pencil sharpener and sharpen the old wood pencil. So I've given competitor 1 a 3 and competitor 2 a 1 on the scale of easy to sharpen. And then in terms of easy to erase, well, they're about the same. The lead gets pushed into the paper the same amount. The eraser is just as easy to use in either case. And so I've got both of them rated as a 2. And then what I'll do is just connect the data points to each other. So you can see this purple connection represents competitor 1, and this green connection represents competitor 2. And there are more instances where competitor 1 does better in meeting the customer needs than competitor 2. And so I come to the conclusion that competitor 1 is the superior product for meeting this particular set of customer needs. So I'm going to use competitor 1 moving forward with my additional analysis. Okay, so this section of the diagram is where I'm going to compare what my company is producing, my solution, to the best of the existing competitors on the market, using essentially the same technique that I used up here. But instead of comparing meeting customer requirements, what I'm doing here is comparing engineering requirements. So how well the engineering requirements are met by these particular designs. So with my company, again, here's 3, 2, and 1, 3 being good, 1 being bad. With my company, the large lead thickness is far superior to that of competitor 1, because my lead thickness is 1.3 millimeters. This lead thickness is 0.7 millimeters. So I give myself a 3 and give them a 1. With respect to one push actuation, well, both my mechanical pencil and the competitor's mechanical pencil just require one push actuation, so I give them both a rating of 3. And then here, with respect to eraser ease, one pass erasing, my mechanical pencil and the competitor's mechanical pencil, I give a rating of 2, because again, the actuation to get the lead out and the eraser are both in the same component of the pencil for both cases, and so it's not an ideal solution, but it's not terrible either, so I give that a rating of 2. And then just like before, I come in and I draw the lines. Mine is this orange color, and the competitor's is this purple color, and what I'm looking for is that my line is superior to the competitor's line across at least all of the engineering requirements that are considered most important. And if that is the case, then I've got a good design and I can proceed with the next step, which is looking at design for manufacturing. If it turns out that the existing competitor is better than my proposed solution in meeting all the engineering requirements, then I need to go back to my design process and come up with something better. That means I've essentially failed the process. Okay, so I said this was going to be the last video, but I spoke a little longer than I had intended. I'm actually way over my 7-minute mark, so I'm going to pause here one last time, and we'll pick it up with one more video while I will wrap up the last stage of the House of Quality Analysis. Sorry about that. Please stand by.